Hello everyone, this is about moment of a 3D force, about a point, and about an inclined axis. Scalar and vector approaches, part 1, and there are 10 problems here from levels 1 to 10. So the principles and discussions of this will be on vectors and its applications in the preceding videos. Level 1 problem. The three forces act perpendicular to the rectangular plate as shown. Determine the moments m1 of F1, moment of m2 of F2, and moment of m3 of F3 all about point O. So the moment of each of the force about point O. So this is the way I solved it. First, I apply scalar approach by right thumb rule, then the vector approach afterwards. For F1, it is parallel to the x-axis, so it has no moment. Then it has no moment about OX, but about OY there is. So position your right thumb towards the positive y-axis. The curling of your forefingers would be in this sense. So that's the positive moment about the y-axis, about OY. But F1 is opposite to that. Its moment is in that direction. Therefore, by scalar approach, the moment of F1 about OY is negative F1 times C. So again, your right thumb should be on this positive y-axis. You curl your forefingers, it will be in this sense. But the moment of F1 is opposite, so F1 times C, so that's why it is negative F1C. Moment about OZ of F1 is, again, moment about OX is 0 because it is parallel to. It is discussed on the door, remember? Door force on the doorknob. Then forces parallel to the axis will have no tendency to produce moment. Then if it also passes through that axis. So there's no moment about OZ also because F1 acts on the Z axis. So the only moment is M1Z. In vector form, this is negative F1CJ. So that's the answer. Then in vector form, that's R from O to F1. So that position vector is CK towards the positive z-axis. CK cross with the force. The force is opposite to the positive x-axis, so it is in vector form, it is negative F1I. And since K cross I, K, your forefingers would be here towards the z-axis, curl it towards the y-axis, towards the x-axis. Your right thumb will point the positive y-axis. Again, your forefingers towards the z-axis, curl it K, curl it towards the x-axis. Your right thumb will be positioning towards the y-axis, and that is positive J. So it is negative F1C, then K cross I is positive J. Negative F1C, K cross I is positive J. So that's why in vector form, moment of F1 about O is negative F1CJ. Now how about the moment of F2 about point O? OX, it's 0 again because it is parallel to OY. Your right thumb towards the positive y-axis, your forefingers will be curling in this sense, which is the same moment as F2. So it is positive F2 times C, MOY. So M2Y is F2C. Then about z-axis, your right thumb should be here. Right thumb, then this is the curling of your forefingers. This is the positive sense of moment about OZ due to F2. That sense, but F2 is opposite. So therefore, M2Z is negative F2 times B. So if we answer this in right away, this is the scalar approach, then it is F2CJ minus F2BK, or F2 times quantity Cj minus Bk. So by scalar approach, that's the answer. By the vector approach, it is RO to the line of action of F2. So that position vector from O to the line of action of F2 is Bj plus Ck cross F2. And F2 is pointing the positive x-axis, so in vector form, F2 is F2i. Again, the position vector from O to the line point on the line of action of F2 is that position vector, and that is Bj towards the positive y-axis, B direction, then positive Ck. So M2 is Bj plus Ck cross F2, and F2 in vector form is F2i. So we have F2b j cross I, then F2c k cross I. So F2b j cross I, F2c k cross I. So j cross I, your forefinger should be coming from the y-axis, curl it towards the x-axis I, then your right thumb will be pointing downward. So that is negative k. So this is negative k. Then k cross I is your forefinger should be from the z-axis, curl it towards the I or the x-axis. Forefingers towards the z-axis, curl it towards the x-axis. Your right thumb will be pointing the y-axis. So this is equal to j. So negative k, F2b negative k, then F2c positive j. So therefore, M2 is the same as that in vector form. Then finally, the moment of F3 about O. OX, it is parallel to, no? OY, it is also 0 because it acts on the y-axis. MOZ only. Your right thumb again, for the positive sense of moment, would be here. Your forefingers will be curling in that sense. So positive movement would be in that sense. But the moment of F3 about the z-axis, OZ axis, is opposite. So by scalar approach, it is negative F3 times B. And that's the only moment. So in vector form, because this is Z, it is negative F3B K. This should be the answer in red one. If we solve this in vector approach, R O to F3, that's BJ cross F3. F3 again in vector form because it is towards the positive x-axis is F3i. So it is BJ cross F3i. And again, J cross I is negative K. J cross I is negative K. So it is F3 times negative K or negative F3 BK as expected. So remember, I solved this by scalar approach, right thumb rule, and by the vector approach. This is level 1, so you should be able to understand it because I solved it into two ways. So you have to practice right thumb rule. So level 2 problem, again, let's solve this into two-way scalar and vector approach. Determine the moment of the force F about point O, about point A, and about line OB. So first, about O. So by scalar approach, we should evaluate MOX, MOY, and MOZ by right thumb rule. So if your right thumb would be here, the curling of your forefingers would be in that sense. So the positive moment about OX by right thumb rule is in that sense. But F is in the opposite sense. So moment about OX by scalar approach is negative F times moment arm C. About OY, it is 0. So I will not mention it here by scalar approach because it is parallel to y. About z, if this is your right thumb, your forefingers will curl in that sense. That's a positive moment. And f is also in the same sense. So therefore, MOZ due to f is f times a. MOZ is f times a. Therefore, in vector form, although this is scalar approach, it is negative FCI plus FAK. MO is negative FCI plus FAK. If we factor out F, then that is F times negative CI plus AK. Moment about point A. This is point A. So this is AX, but the line of action of F passes through AX. So moment about AX is 0. Moment about OY is 0 also because F is parallel to AY. Then it has only moment about Z. If this is your right thumb, again, the curling of your forefingers would be in that sense. Right thumb, then forefingers. 4, 1, 2, 3, 4, or 4 FORE fingers will curl in that sense. So same sense as the moment of F. So it is MOZ is FA. So by vector approach, MO is RO to the line of action of F cross F. F in vector form because it is pointing towards the y-axis is Fj. Now O to this line of action, this is one line of action of the force. It may also be here, but this is simpler, is AI plus CK. AI plus CK, there's no movement along Y. So AI plus CK, that's the position vector from O to this point here. AI plus CK cross the force in vector form, it is Fj. So we have Fa, I cross J, then Fc, K cross J. Again, I cross J, I, four fingers here, cross, curl it towards the y-axis. Your right thumb will be pointing the z-axis, and that is K. So I cross J is K. K cross J, K cross J, your four fingers would be here, curl it towards the J or y-axis. Your right thumb would be in that opposite to the x-axis. J, four fingers pointing upward, curl it towards the y. Your right thumb will be in the opposite x direction, and that is negative I. So that's why MO is F times negative CI plus AK by the vector approach. Then moment about OB. It is R position vector cross F in vector form, then unit vector of OB. So MA, by the way, MAX is 0 because F passes through the AX axis. MAY is 0 because it is parallel to. MAZ only, that's the positive sense of MAZ. And it is F times A. That's why. In vector form, this is scalar approach, but if you express the answer in vector form, it is FAK. This should have been the answer, but let's answer this by vector approach. So R from A to this point, that's AI, cross F, which is FJ. So R, AI cross FJ. So it is FA, then remember I cross J is positive K. Four fingers here, curl it towards the y-axis. Your right thumb will be pointing the z-axis, and that is K. And that's why it is FAK. Then moment about OB in vector form. So MOB is CK cross FJ, that unit vector of OB. It is a scalar. Position vector cross FJ, that lambda OB. Now we will not use from O to line of action of F, which is here, because there are two components. Instead, this is the other end of OB. So B to this point here, this is the line of action point on the line of action of F, and this is simpler. This direction is along Z only, so that is CK. Cross the force in vector form, the force is Fj towards the positive y-axis. Then unit vector of OB, which is direction OB divided by magnitude of that direction, which is in vector form, OB is AI plus BJ divided by square root of A square plus B square. So the technique here is component of the first, which is 0, 0, C, K, 0x, 0y, then C. Components of force, which is along y only, so 0f, 0. Then lambda of OB is again AI plus BJ over square root of A square plus B square. So along along x, A over square root of A square plus B square. Along y, this is B over square root of A square plus B square. This is only CK cross FJ, not yet uh, components of unit vector, by the way, and the last. So this is AI over square root of A square plus B square, BJ over square root of A square plus B square, and 0K. There's no movement along Z. Then copy the elements of the first two columns, then apply product. So 0 times F times 0, 0. 0 times 0, 0. C times 0 times B, 0. Then this is 0, that is 0. The only diagonal product with value is this, and that is minus. So this is negative FAC over square root of A square plus B square. So that's the result of this scalar typal product. Now, if you want to express this in vector, we multiply this by the unit vector of OB. The unit vector of OB is again AI plus BJ over square root of A square plus B square. So this is the scalar value. Then we multiply unit vector of OB, which is AI plus BI. This is OB direction, then divided by its magnitude, it becomes the unit vector. So the final answer is negative FAC quantity AI plus BJ over A square plus B square. That's the moment about OB in vector form. Level 3 problem. A right angle bracket is welded to the flange of the I-beam to support the 9,000 pound force applied parallel to the axis of the beam, and the 5,000 pound force applied in the end plane of the beam. In analyzing the capacity of the beam to withstand the applied loads in the design stage, it is convenient to replace the forces by an equivalent force at O and a corresponding couple M. So determine the X, Y, and Z components of M. So just the X, Y, and Z components of M. So in this case, there's no need to apply vector approach. We just use scalar approach and the right thumb rule. So let us compute the components of this 5,000 pound force. The components are rightward, so 5,000 cosine 30, and downward along Y, 5,000 sine 30. So the components are, I just write it right away, 5,000 cosine 30 is 4,330 pounds rightward, and 5,000 sine of 30, this one, is 2,500. So moment about X, 4333, 0 is parallel, so no moment. 2,500, because it is on the end plane, it passes through the x-axis, so no moment. Same plane as xy plane, so no moment about x. Only 9,000 will have moment about x. Now, if this is your right thumb towards the positive x-axis, the curling of your four fingers for positive moment is that sense, which is the same moment as 9,000. It is coming down, then it will rise, rotating about the x-axis in that sense. And this is also, if this is your right thumb, these are also your four fingers curling in the same sense. So the moment, therefore, about x, OX is positive 9,000 times 6 plus 8, 14. So MOX is 9 kips times 14. So it is 126 kip inches. MOY, this is the y-axis. 4330, same plane as xy plane, passes through the y-axis, so no moment. 2,500, parallel to the y-axis, no moment. So only the 9,000 will have moment. Now, if this is your right thumb, the curling of your forefinger should be in that sense. Again, the positive sense of moment is in that sense. The moment of the 9 kip force is opposite. It is opposite to that sense. It is from the left, then it rotates to the left. So therefore, it is negative 9 kips times 4. MOY is negative 9 times 4. It is negative 36 kip inches. Finally, moment about the z-axis. If this is your right thumb, the curling of your forefingers would be in that sense. Again, the positive moment about the z is in that sense. This is the arrow direction. 9 kips is parallel, so no moment. 4.33 kips, same sense, so positive. 2,500 in the opposite sense, negative. So it is 4.33 times 14, then minus 2.5 times 4, because this is also the z-axis. So 4.33 times 14, this is the z-axis. Same sense, this is your right thumb, that's the four fingers. That's the positive sense of moment. So 4.33 times 14 minus 2.5 times 4. That is 50.62 kip inches. Remember that I solved this by right thumb rule. That's the scalar approach. Level 4, a space orbiter is subjected to the thrust from 5 of the engines of its reaction control system. 4 of the thrusts are shown in the figure. The fifth is an 850 Newton upward at the right rear, symmetric to the 850 Newton thrust shown on the left rear. Compute the moment of these forces about point G and show that the forces have the same moment about all points. So let's compute the moment of these 4 forces about point G. So remember that there is 850 here hidden. 850 plus 850 upward is on a symmetric axis is 1,700, also same as that. So first, moment about the x-axis. This is the x-axis. 1,700 acts on the x-axis. Same plane, 1,700 also. Then we have 850 right, 850 left, so same moment, so it will just cancel about OX. So no moment for these two, no moment for the two upward 850 force. But this 1,700 Newton has moment because it is 2 meters above the XY plane. So therefore, it is 2 meters above the x-axis. Then if this is your right thumb, the positive moment about x is in that sense. In that sense, which is the same moment as 1,700 times 2. So therefore, mgx rather is 1,700 times 2. It is equal to 3,400 Newton meter. MOY, this is the y-axis. This is your right thumb. Then four fingers will be curling in that sense. Four fingers will be curling in that sense. So 1,700 rightward and 1,700 leftward will have no moment because they are parallel to the y-axis. Therefore, only these vertical forces will have moment about the y-axis. Beginning with 850, again, right thumb, so positive sense would be in that direction. The moment of the two 850 is in the opposite direction, so they are negative. Moment of this 1700 force is also in the opposite direction, so negative. So it is negative 2 times 850 times 12, then negative 1700 times 18. So mgy is negative 51,000 Newton meter. Finally, mgz. The z-axis is positive, z-axis is downward. This is your right thumb. The positive sense of moment would be in that sense. Positive sense of moment would be in that sense. So these vertical forces will have no moment about the z-axis because they are parallel to the z-axis. Only these two 1700 Newton forces. Positive or negative? It's negative because the positive sense of moment is in that sense. The moment of 1700 opposite sense. Opposite sense. Again, the positive moment is in that direction. This is your right thumb, four fingers in that sense. 1700 times 18 is opposite, negative 1700 times 18, then negative 1700 times 12. So mgz is negative 1700 times 18, then negative 1700 times 12. So mgz is equal to negative 51,000 Newton meter also. In vector form, the given forces, by the way, constitute couples. Do you notice that they are couples? 1700 downward, 1700 upward, 850 times 2. That's a couple. Another couple is 1700 right, 1700 left. That's a couple. And couples are independent of moment centers. So regardless of which point you choose, the moment would be the same. That's why that's the answer to show that the forces have the same moment about all points because they are couples. So in vector form, mg is 3400I minus 51,000 J minus 51,000 K Newton meter. Level 5 problem. Replace the two forces which act on the 3 meter cube by an equivalent single force F at A and a couple M. So let us first resolve the 40 kilonewton load into its components, which is towards the positive y-axis and towards the positive z-axis. It has no x component. Same issue here without x component. It is towards the negative y-axis. So that's 40. This is 45 or 40 times 3 over 3 square root of 2. 28.8. This is also 28.8. So again, 40 times cosine of 45 or 40 times 1 over square root of 2. The slope is 1 vertical, 1 horizontal, square root of the hypotenuse. So therefore, fx is 0. Fy is 28.8 minus 30. So 0 along x, 28.8 minus 30j, then positive 28.28k. So the force that will replace the system by an equivalent force and moment or couple is negative 1.72j plus 28.28k kilonewtons in vector form. Then moment about ax. So this is ax. Your right thumb should be there. Then the curling of your four fingers would be in that sense. So the positive moment would be in that sense, which is the same sense as 30 times 3. 30 times 3 because this is 3 and this is ax axis. So 30 times 3, this horizontal 28.8 passes through the ax axis to 0, but this 28.28 vertical upward force is negative sense. So 30, again, your right thumb would be there. Curling of your four fingers would be this. So that's why 30 times 3 minus 28.28 times 3. MAX is 30 times 3 minus 28.28 times 3. By scalar approach, MAX is 5.16 kilonewton meter. MAY, because this is the AY axis and this force acts on the Y axis, so zero moment. This one is parallel to the Y axis, so zero moment. Therefore, there's no moment about Y. MAY is zero. Then MAZ, this is the AZ axis. Your right thumb should be here. Then the curling of your forefingers for positive moment would be in this sense. This is passing through AZ, so zero, this component of force. This is parallel to AZ, so zero also. So let's concentrate to 30. So the moment positive sense is in that sense, because this is the AZ axis, your right thumb would be there, forefingers would be curling in that sense. But the moment of 30 is in the opposite direction. So therefore it is negative 30 times 3. MAZ is negative 30 times 3. Negative 90 kilonewton meter. So the force couple that is equivalent to this system here is this is the force and this is the couple. In vector form, 5.16 I minus 90 K kilonewton meter. Level 6, a helicopter is shown here with certain three-dimensional geometry given. During a ground test, a 400 Newton aerodynamic force is applied to the tail rotor at P as shown. Determine the moment of this force about point O of the airframe. So this is the force. Then that's the moment of the force about O. In scalar approach, we have to evaluate MOX, MOY, and MOZ. So let's apply a scalar approach. Your right thumb should be here. Then the curling of your forefingers for positive moment would be in that sense. And this is same, 400 times 1.2. So MOX is 400 times 1.2 by scalar approach, 480 Newton meter. MOY, your right thumb should be here. The sense is, in that sense, parallel to y-axis, so it has no moment about OY, 0. MOG, your right thumb should be here. The curling of your forefinger should be in that sense, which is the same sense as 400 times 6. So MOZ is positive 400 times 6. So 2,400 Newton meter. Therefore, the moment about O of this force is, in vector form, is 480 I plus 2,440 K Newton meter. Level 7. A 50 Newton horizontal force is applied to the handle of the industrial water valve as shown. The force is perpendicular to the vertical plane containing line OA of the handle. Determine the equivalent force couple system at point O. So let's express this force in vector form so that we can analyze it. We draw the top view so that we can express F in vector form. So this is the top view. This is the positive x-axis, positive y-axis, and the z-axis is pointing your eyes. So therefore, Fx is going in the opposite direction. It is negative 50 cosine of 40, Fx. And that is negative 38.3 newtons. Fy is going to this component is to the left, so opposite of y. So Fy is negative 50 sine of 40. So therefore, it is negative 32.14 newtons. There's no Fz because it is stated here this force is horizontal, so parallel to the xy plane. So therefore, moment about OX, this component Fy is to the left, it is above the x-axis. Positive sense of moment, this is your right thumb, so positive sense of moment is in that sense, which is the same sense as this component of force, which is 32.14, do not carry the sign. It is pointing to the left. It is above. It has the same sense as the positive sense of moment about OX. So MOX by scalar approach is 32.14 times 20 mm because it is 20 mm above the XY plane, this force here. By the way, in vector form, F is negative 38.3 I, negative 32.14 J. Again, MOX is, this is Fy in that sense, same sense as positive moment about OX, because if this is your right thumb, the four fingers will have this curling. So it is 32.14 times 20 mm. But we will solve this by vector approach later. 642.8 to verify, Newton mm. Then Fy, if this is your right thumb, the positive sense of moment is from the rear forward. So this is the positive sense of moment. This is Fx backward, and its moment about y is going down, curl going down. The positive sense of moment is curl forward. So it is negative 38.3. Not that Fx is negative, it's the sense. It is negative or positive 38.3 times 20. So negative of 38.3, it's not negative Fx times 20, it is negative of 38.3, just the sense, not the sign of Fx times 20, because it should be negative. Because the positive sense is in that sense, then the moment is in the opposite direction. So negative 766 Newton mm. Then moment about OZ, because this is perpendicular to this handle here, that one, and this is the z-axis. The positive sense of moment, the curling of your four fingers would be about the z-axis with this. This is your right thumb. These are your four fingers. So this is the positive sense, which is the same moment as 50. So positive 50 times 125, because the distance is 125. So 6 to 50 Newton mm. Before answering moment about O in vector form, you just put I, J, K here. Let's solve it by vector approach. So MO is supposedly ROA. OA cross the force. Where OA is, we have to move backward by the distance in the figure. So this is 125. So this horizontal distance along Y is 125 cosine 40. It is 95.76. That distance is 125 sine 40, 80.35. So from O, we go backward opposite to the x-axis, negative 80.35 I, then rightward 95.76 J, then after that upward by 20 for K. So this is in determinant form, negative 80.35 I, 95.76 J, then upward 20 along Z, so 20. Then components of force, X, Y, Z component of force. Then unit vectors I, J, K. Then copy the first two columns. So for I, 95.76 times 0, so 0, minus negative 32.14 times 20. So it is positive 32.14 times 20, which is that, 642.8. Then for J, 20 times negative 38.3, negative, then minus 0, because there is 0 here. So 20 times negative 38.8, it is this one, negative 766 along J. Then along K, negative, negative, so 80.35 times 32.14, treat that positive, minus negative 38.3 times 95.76, so that becomes plus. 80.35 times 32.14, then plus 38.3 times 95.76. That would give us 6250. Use your calculator. So therefore, final answer for MO is 642.8I minus 766J plus 6250K. Level 8, using the principles to be developed later on equilibrium, one can determine that the tension in cable AB is 143.4 newtons. Determine the moment about the x-axis of this tension force acting on point A. Compare your result with the moment of the weight W of the 15 kilogram uniform plate about the x-axis. What is the moment of the tension force acting at A about line OB? So first, let's compute for the distance. So this plate, inclined plate, is 0.45 meter and it is depressed 20 degrees. Therefore, the distance along the y-axis is 0.45 cosine 20 and this vertical distance is 0.45 sine 20. So 0.45 cosine 20 is 0.4229. 0.45 sine of 20 is this distance here is 0.1539. Therefore, in vector form, the force with magnitude 140.4 is directed from A to B. So along X, you go backward 0.35 because that's also 0.35. Half of 0.7 is 0.35. Then going to the left, opposite to the Y is 0.4229 negative. So this is negative 0.35I, negative 0.4229J, then up by 0.1539 plus zero point 0.4, so 0.5539K. So these are the components. F is 140.4 times quantity negative 0.35I, negative 0.4229J plus 0.5539K, where 0.5539 is 0.1539 plus zero point 0.4, divided by magnitude of direction 0.35 square plus 0.429 square plus 0.5539 square. So F is negative 64.36I, negative 77.76J, 101.9K. So this is Fx towards the negative x direction. That's why it's negative. This is Fy towards the negative direction, 77.76, and this is Fg. Now this is the tension force, and this is the x-axis. If this is your right thumb, the positive sense by scalar approach is in that sense. Therefore, this is Fx parallel to the x-axis, has no moment. This z component will have the same sense, positive sense, so its moment is positive, while this y component is negative. It comes from below, then it curled that way. The positive moment is, the curling is in that sense. So this is Fz, 101.9, the moment arm is 0.4229, then minus this component, which is Fy, 77.76, moment arm is 0.1539. So MOX is 101.9 Fz times 0.4229 minus Fy, which is, do not carry the sign, make it positive because it is leftward, minus 77.76 times 0.1539. So MOX is equal to 31.13 Newton meter. Now how about the moment of the weight? This is OX, the positive sense is in that direction, then the moment of the weight is in the opposite direction. So it is negative. It should be expected, the negative of this value. But because we round off distances, they are just almost equal but opposite in sense. So it is negative weight 15 times kilograms times 9.81 newtons per kilogram. Its moment arm is half of 0.4229. So half of 0.4229 because that's the center of gravity of this door. 0.4229 over 2. So MOX of the weight is negative 31.11. So as expected, they are not equal because of rounding off of these distances. Or maybe the force tension is 140 point something, That's rounded off to 4 significant figures only. What is the moment of the tension force acting at A about line OB? So you have to apply cross product ROB cross tension, but because you have to do that, OB direction is 0.35I, 0.4K, cross the force in vector form, then you have to show that it is zero. So the answer is automatic zero. Why? Because the tension force passes through B, and B is on the axis OB. So I have to answer it very shortly by common sense. It's up to you to show that it is zero. So MOB is zero. Level 9, the special purpose milling cutter is subjected to the force of 1,200 newtons and a couple of 240 Newton meter as shown. Determine the moment of the system about O. So we have a wrench actually, we call this a wrench. So let's resolve the force into its components as well as this couple here. Remember, the couple is independent of its moment center, so you can move it directly to O after we change it into vector form, computing its components. So the force is 1,200. The components are negative along Z and positive along Y. So along Y, it is 1,200 sine 60 I. Along Z, negative 1,200 cosine of 60 J. So F is 1,200 quantity sine of 60 degrees J along Y, then minus cosine 60 K times 1,200. So it has no X component because it is parallel to the YZ plane. So F is 1039 J minus 600 K newtons. That's the force. But the question is moment of the system about O only. So let's solve it into two ways, scalar and the vector approach. So the couple is your right thumb should be in that direction. Imagine this is double arrow instead of the curling. So right thumb in that direction, then curl it. Your right thumb will be pointing in that direction. So the components of the couple would be along Y positive and along Z negative. So it is 240 sine of 60 J again positive along Y, then negative along Z cosine 60K. So couple is 207.8 J minus 120 K Newton meter. Now how about the moment of these components? Let's put the components here. So 1,200, this is 1,039 along Y positive and along Z negative 600 towards the negative Z direction. So if we compute moment about X, this 600, because it lies on the XZ plane, will pass through X, so it has no moment about X. Only this 1039. If this is your right thumb, the positive sense would be in this direction. The moment of 1039 is in the opposite direction. So moment about OX for this component of force is negative 1039 times 0.25 plus, no, we have to plus because there is no I here, just that one, negative 1039 times 0.25. So it is negative 259.8 Newton meter. Moment about Y, if this is your right thumb, the curling of your forefingers would be that sense. So positive moment in that sense. 1039 is parallel to, so it has no moment about Y, just this 600. Since this is the positive sense and 600 will curl in the same sense, so moment of 600 about the Y-axis is positive, 600 times 0.2. Then we have here 207.8 due to the component of the couple. So MOY therefore is 207.8 plus 600 times 0.2. So MOY is 327.8 Newton meter. Finally, MOZ, We have negative 120 due to the couple component. Then this is the z-axis. If this is your right thumb, the positive sense is in that sense. 600 is parallel to, so it has no moment, just this 1039. And since the sense of moment about the z-axis positive is in that sense, same as 1039 times zero point 0.2. So it is negative 120 plus 1039 times zero point 0.2. So therefore, MOZ is 87.8 Newton meter. So we can now answer the moment in vector form. In vector form, solution, that's scalar. It is ROF. I just call this F here, line of action of the force. ROF plus the couple, which is already computed. This position vector is going to the x-axis 0.2, 0.2i, then forward along the z-axis 0.25 k. So ROF is 0.2i plus 0.25 k, no y-axis, no movement along y. So this is in matrix form 0.2, 0, 0.25. Components of force, 0 along x, 1039 along y, negative 600 along z. Then unit vectors ijk, copy the elements of the first two columns. Then it's like evaluating the determinant. Plus the couple 207.8. So we'll just expand this part, then we add it later here. For I, 0 times negative 600, that's 0. Then minus 1039 times 0.25. That's why we have here negative 1039 times 0.25. Then for J, so that's definitely negative 259.8i. For J, 0.25 times 0, so 0. Then minus negative 600 times 0.2, so that's positive 600 times 0.2. That's why we have 600 times 0.2 here. Then plus 207.8. For K, 0.2 times 1039, then 0 times 0, minus 0 times 0, 0. So that's why we have here 0.2 times 1039, then minus 120. So it's the same. Negative 259.8i plus 120j plus 207.8 plus 207.8j minus 120k. It will add up to negative 259.8i plus 327.8j plus 87.8k Newton meter. So that's it. Then lastly, level 10 problem, but this is simple. Four forces are applied to the machine component ABDE as shown. Replace these forces by an equivalent force couple system at A. So for the force, Fx is negative 300, negative 120. So that's negative 300, negative 120, negative 420 newtons. Fy is negative 50, opposite to the positive y-axis. Then Fz is negative 250. So therefore, the force is in vector form negative 420i, negative 50j, negative 250k newtons. For the moment about A, so moment about AX is this. So these two forces parallel and it acts on the x-axis, so we'll have no moment. This 250 here passes through the x-axis, so no moment. And this one is parallel to the x-axis, so no moment. So MAX is 0. MAY, this is the y-axis. This is parallel to the y-axis, no moment. 300 is passing to the AY axis, so no moment. This is also parallel to the, this passes through AY, so no moment. So just this 250 and 120 here will have moment about the y-axis. Right thumb towards the y-axis, the positive sense would be in that sense. Positive moment about AY is that sense, which is same sense as 250 times 0.2, 0.2 meter, 200 mm. So that's positive. And this is opposite sense, 120 times 0.16. So therefore, moment about AY is positive 250 times 0.2, then minus 120 opposite times 0.16. So MAY is 250 times 0.2 minus 120 times 0.16. So MAY is 30.8 Newton meter. Finally, moment about Z. This is your right thumb. The curling of your forefingers for positive moment would be in that sense. In that sense, positive. Passes to 300. 250 is parallel. So the only forces with moment about the Z-axis would be 50 and 120. So again, the positive sense of moment is in that sense. Let's begin with 150. It is in the opposite sense because positive moment is from bottom going up, then curl in that direction. This is in the opposite direction from top going to bottom, then up. So negative 50 times 0.2. This is also negative 120 times 0.1. Because imagine this is the z-axis also. So moment about AZ is negative 50 times 0.2 minus 120 times 0.1. So MAZ is negative 22 Newton meter. In vector form, 30.8 J minus 22 K Newton meter. That's it.